same limits are here. The limits are 0 to 1 again. This is 5 x cube means 5 upon 4 dt. Or this is dt upon 4, that means dt upon 5 is there. X cube dx equal to dt upon 4 divided by 1 minus t square. Because in place of x4 we have substituted t only. This is t square here, t square. This is, let me take 5 by 4 out of sign of integration. This is dt upon under root 1 minus t square. Now this is nothing but sin inverse t. This is equal to, sorry, limits are 0 to 1. This is 5 upon 4 sin inverse t. So we know that under root 1 upon under root 1 minus t square, 1 minus x square equal to sin inverse x. This is sin inverse t. Now substituting the limits here, this is 0, sorry, 0 to 1. So 5 by 4 into first is sin inverse upper limit 1 minus sin inverse 0. This is sin inverse 1. Sin theta is 1 for theta equal to 90 degree. That means pi by 4. This is pi by 2, sorry. 90 degree means pi by 2. Radian. This is 0 here. Sin 0 is 0. 5 by 4 into 0 is 0. That is 0. This means only 5 upon 8. 5 pi by 8. This 5 pi upon 8. That clearly. 5 pi upon 8 go to the 8. This is the answer here. Okay. The final answer is this question number 5th we have done. Now let's talk about question number 6th. Okay. Now question number 6th. What is the question number 6th? Okay. Question number 6th. It says 0 to a. It is x square sin x cube into dx. Okay, is it repeated one? I think this is 0 to a. The same question, let me write here cos x cube. It will be different then. That is 0 to a x square sin x cube dx. Because in the 25th question also, the same question are repeated. That are taken as cos x cube. The answer will be different then. Now let me substitute here. Let x cube, the angle of sine is equal to t. Again differentiating it with respect to t, we will get 3x square into dx equal to dt. Simple as that it is. This is just after differentiation with respect to t. Okay. This is 3x square into dx upon dt equal to 1. Take dt to that side, it will be different. Now limits are. Now let me talk about limits. Let me take now upper limit. When x equal to a, the upper limit here, then t is equal to a cube. Because x cube means a cube. In place of x, we have to substitute the limits. And when x equal to 0, then t is also 0. Because this is the whole cube. Okay, so t is equal to, from this x is 0, 0 whole cube, that is 0. 0 to a cube is the limits, or the limit. 0 to a cube are the limits. This is for x square, or let me first write it in proper manner. Let me reassemble it. It is 0 to a, the same value are not, it still changed. This is into x square into dx. This value 0 to a, sorry, 0 to, now converted this 0 to a cube, substituting the variable t. This is dt. Okay, dt upon 3. So x square, this is 1 x square dx equal to dt upon 3. It will be upon 3 also, that means 1.3 are taken out. The sign of integration is 0 to a cube sin t into dt. Sorry, let me repeat this. So it will be minus cos t. Integration of sin t is minus cos t, 0 to aq. Final answer will be, let me talk about, this is 1.3 minus sin cos t cos aq. Now aq is not a value, is a constant term. Cos aq is constant, so it's a constant value. Okay, not a. Okay. Minus sign, for in between we do the minus sign, between plus sign, then cos 0. But cos 0 is for what value? Cos pi by 2. Okay, because cos, I'm sorry, this is angle. Cos 0 is 1. It will be 1 here. It is nothing but cos 0 is 1. Maximum value. This is 1 minus cos 80 minus cos 80 plus 1. This is 1.3. 1 minus cos 80. This is the answer. Because here it is not inverse form, just cos 0. Cos 0 is 1. Because for 0, the value of cos is 1. Maximum value. As sin 90 is 1. Similarly, cos 0 is 1. So this is the answer here. 1.3, 1 minus cos aq. Okay. This is the final answer. Question number 6. We have done. Now let's talk about question number 7. What is the question number 7 say? Question number 7 here is sine of integration 1 to root 3. Okay, it is tan inverse x upon 1 plus x square dx. This one. It is tan inverse x upon 1 plus x square. So let's talk about the, let's substitute, let tan inverse x equal to t. It means 1 upon 1 plus x square, differentiating with respect to t into dx upon dt equal to 1. This is after differentiating. Let me take differentiating it with respect to t. So we get the same thing. Because differentiation of tan inverse x is 1 upon 1 plus x square into differentiation of x is dx upon dt equal to differentiation of t with respect to t is 1. That is 1. So it is nothing but dx upon 1 plus x square is, sorry, into equal to dt. Now limits, let me substitute. Where are the limits? Okay, when x equal to root 3, let me take the upper limit first. When x equal to root 3, then t is equal to, then t equal to tan inverse, it is root 3. Tan inverse, tan root 3 is for angle pi by 3, that is 60 degree. It is nothing but pi by 3. Pi by 3. Okay. This is pi by 3 or 30 degree. So pi by 3 for root 3. Now when 1 and let me write here, and when x equal to 1, the lower limit, then t is equal to, then t is equal to tan inverse 1. So tan inverse 1 is for pi by 4. 45 degree is for 1. So tan 45 degree equal to 1. Now tan inverse 1 is equal to pi by 4. So this is pi by 4. That means limits are now pi by 4 to pi by 3. 45 degree to 60 degree. It's in degrees. It is now dt upon, sorry, only t dt. t dt dx upon this is dt. T into dt only. This will be t square upon 2. Limits are pi by 4 to pi by 3. Now substitute the limits here. What are the limits? In place of t, you have to substitute pi by 3 first. This will be pi by 3 whole square upon 2 minus this is pi by 4 whole square upon 2, that will take 1.2 common. It will be pi square upon 9 minus pi square upon 16. If I solve it, pi square is also common. It is pi square upon 2 out of the bracket. LCM is 144. Let me multiply this. It is 144. 1600. Okay, so 150, 144, sorry. This is 9 into 16. 1600, 144. So therefore 16 minus 9 pi square after you come, this is 1.9 minus 1.16. That means 16 minus 9 is 7, which is 7 pi square upon 288. This is the answer here. If 16 minus 9 means 7, 7 pi square upon 2 into 124, sorry 144, that is 288. This is the answer here. Final answer 7 pi square upon 288. Okay. This is the answer. Question number 7 is done. Is solved. Now let me talk about question number 8. Now question number 8 is, what is question number 8? Okay, now let me take question number 8 here. Question number 8. What does it say? Let me tell you. Question number 8 says, okay, this is similar type of 0 to 1. This is tan inverse x whole square upon 1 plus x square dx. Okay, now again let us take that tan inverse x equal to t. Therefore differentiating with respect to t, we get, it will be 1 upon 1 plus x square into dx equal to, let me take that dt. This is the value here. Tan inverse x equal to, okay. Now the limits, again the same type of limits are there. When x equal to 1, the upper limit, when x equal to 1, then t equal to tan inverse 1, that is pi by 4. This is pi by 4 here. Their limits are different here. 0 to 1, previously it was 1 to 2, 3. Okay, no problem. This is pi by 4 here. And when t equal to 0, then, sorry, when x equal to 0, sorry. When x equal to 0, then t equal to tan inverse 0, and it is for 0 degree. For 0 degree, tan inverse 0 is 0. This is 0 to pi by 4. Finally, limits are 0 to pi by 4. Here it is t square dt for dx upon 1 plus x square equal to dt. And this is t square we have achieved. So integration will be t cube upon 3. This is just a polynomial type of function or algebraic function. T cube upon 3. This integration 0 to pi by 4. So the value will be pi by 4 whole cube upon 3. This is 0 because we will substitute 0 in place of t. 0. This is nothing but this one. This is pi cube upon 4 into 4 into 4, 3 times, that means 64. 64 into 3. 4 to the 16, 16 to the 64. So this is pi cube. This is pi cube upon 3 4 is 12, 1 carry, 3 6 is 18, 1 19, 192. This is the answer here. The final answer is, this is pi cube upon 192. 3 4 is 12, 2 1 carry, 3 6 is 18, 190, 192. This is the answer here. So question number 8 we have done. Let's talk about 9th question. Question number 9th now. Okay. Question number 9th. What does it say? Okay, that is the question number 9th. Sign of integration 0 to pi by 3 limits and cos x upon divided divided by 3 plus 4 sin x into dx. Let us assume, substitute. Let 3 plus 4 sin x equal to t. Complete value you have taken as t. Therefore, differentiating it with respect to t. Differentiating it with respect to t. We get this is 0, this is 4 into cos x, because this is differentiation, be positive. Cos dx equal to dt. Now, putting the limits here. Now, limits. First, let me take upper limit when x equal to 5 by 3 here. Then t equal to, this implies that t is equal to 3 plus 4 into sin pi by 3. Okay, this is nothing but 3 plus 4 into root 3 by 2. So sin pi by 3 means sin 60 degree, means root 3 by 2 value. Okay, so this is 3 plus 2 root 3. This is the value here. 3 plus root 2 root 3 upper limit, and when x equal to 0, then t is equal to how much? 3 plus 4 into sin 0, that means 3 only, plus 0, that means 3. For this sin 0 is 0, this is 0, 4 into 0, that is 0, 1 is 3. I'm sorry, so limits are 0 to, 3 to, this is 3 to, okay, 3 plus 2 root 3. Okay, and this is t, and cos x dx equal to t. So that is 4 also. 4 should be taken to the side. So that is cos x into dx equal to dt upon 4. Here the 4, 1.4 are taken to take the complete value. So this is dt upon 4. Let me write it. dt upon 4 in the numerator divided by t. This is equal to 1.4 minus multiplication 3 to root 3 into dt upon t is 1.t only. This is nothing but 1.4 log 1.4 log t. And limits are 3 to 3 plus root 3. So finally, the value we have to substitute in 1.4 common. The first is t is upper limit, that is log of 3 plus 2 root 3. So 2 root 3 minus sin log of 3. Okay, this is the same answer. This is the answer here. We cannot convert them. Okay, we can write them. That's log of this upon this. Okay, let me further solve it. This is nothing but log of 3 plus 2 root 3 upon 3. Log m minus log n is log m upon n. Is m upon n. It can give us 1.4 log of 1 plus 2 upon root 3. Why? Because root 3 upon 3, root 3 if I multiply in the numerator limit with 3 upon 3 root 3, that means 2 upon root 3. 2 upon root 3. The answer here. Okay, so this is final answer. Question number which one? 9th we have done. Let's talk about 10th question. Question number 10th is what? Okay, that is the question number 10. Here we have bottom here. Limits 1 to 2. And question limit 1 to 2. It is 1 plus log of x whole 4 divided by x here into dx. This whole value we have to substitute. Let 1 plus log of x equal differentiating with respect to t, differentiating it with respect to t, we get it is 1 from x, this one is 0 into dx equal to, let me write that dt. So 1 dx upon x equal to dt, we will substitute this, and limits would also be changed. The limits here, upper limit let me take first. When x equal to 2, then t is equal to, this implies that t equal to 1 plus log of 2. Okay, and when x equal to 1, then t equal to 1 plus log 1. Log 1 is 0. This is 1 plus 0. That means 1. So limits are 1 to 1 plus log. Okay. So here limits are 1 to 1 plus log 2. And this is t4 on d into dt. Why? Because this 1 plus log x equal to t. So this whole is t4. This is t4. And this dx upon x is dt. Now let me integrate this. Integration of t4 is t5 upon 5. Limits are 1 to 1 plus log 2. It will be t raised power, that means 1 plus log 2 whole power 5 minus, it is log of, sorry, this one. This is 1 only t raised power 5. That means 1.5 is common. And this is 1, 5. 1 we have substituted in place of t here. It is t means 1 power 5. It is nothing but 1.5. 1 plus log of 2 whole power 5 minus 1. This is the answer here. Final answer is this. This is log of 2 here. Okay, so this is answer here. Question number 10 we have done. Question number 10 is done. Now let me talk about 11th question. Question number 11 is sine of integration 0 to 1. It is dx upon under root 4 minus x square. Okay, we have to change it into either 1 minus t square or something. So let me substitute here. Let x equal to here 2t. That will be 4t square and 4 can be taken common. And therefore dx equal to 2 into dt. Differentiating it with respect to t, we will get dx upon dt equal to 2. So t is 1, and then take dt to that side. Limits are the limits here. When x equal to 1, the upper limit, then x equal to 1, then t equal to 1 upon 2. Okay, this is by the t equal to 1 upon 2. When x equal to 0, t is also 0. When x equal to 0, here if we substitute 0, then 0 upon 2 is 0, t is also 0. Then t is 0. Okay, and when limits are 0 to 1.2, this is dt, 2 dt, sorry, 2 dt upon under root, this is 4 minus 4t square. If I take 4 common, that means 2 will come out. This 2 and this 2 will cancel out. So this is the 0 to 1.2 limits. dt, if we write here 2 upon 2 under root 4 minus t square. This is there. These 2 to cancel out now. After taking common 4 from the under square root, from the square root, it will come out as 2. This 2 to cancel out. So finally the value is 0 to 1.2. It is nothing but dt upon under root 4 minus t square. So this is plus t integration of this 0 to 1.2 limits. Okay, so this is, let me substitute the value sine inverse 1.2 in place of t here is sine inverse 0. Now 1.2 is for pi by 6. Sine value of 30 degree of pi by 6 is 1.2. Pi by 6. This is 0. Sine 0 is 0. Okay, so this 0 is for sine 0. That is 0. This is pi by 6 answer. This is answer. Pi by 6. Pi by 6 is the answer. Okay, final answer is pi upon 6. Okay. Now let me take 12th question. What is the question number 12? See. Now question number 12. Let's talk about okay. Here it is 12th question. Sine of integration is 0 to infinity. 0 to infinity. Dx upon is 9 plus x. Okay. Now it is just like we can directly do this, but I want to substitute and then solve it. Okay. Because we know that what is this? This is 3 square plus x square. That means a square plus x square. That means 1.8 tan inverse x upon a is the answer. Okay, now limits are substituted finally. But I want to just substitute something, then change the limits and the process. So let's substituting x equal to 3t. Okay, because 3t square means 9 square, 9 can be taken in common. So that is therefore dx equal to 3 dt. Limits, what are the limits here? When x equal to infinity, this is infinity. When x equal to infinity, t is also infinity. We change. When x equal to 0, t is 0. Okay. And when x equal to 0, t is also 0. Because a substitute 0, t is 0. X is infinity, t is infinity. We change in the same limits. Okay. Okay, no problem. 0 to infinity. Okay, and this is dx equal to 3 dt. 3 into dt upon 9 plus 9t square. Let me take 9 common from this one. It will be 3 upon 9 means 1.3. Sine of integral 0 to 3 infinity. It will be dt upon 1 plus t square. Now, what we have done, we have taken 9 common from this. This 3 upon 9 will come out, that means 1.3. The same thing, this is 1.3 tan inverse t. Okay, so substituting the value, limits 0 to infinity here. Now limits are 1.3, let me take common, this is tan inverse infinity minus tan inverse 0. Now tan infinity is for 90 degree. Okay, tan inverse means sin 90 upon cos 90. Cos 90 is 0. 1 upon 0 is infinity. Infinity, sorry, this is for 90 degree. And upon 3, this is pi by 0. For 0 is sin 0 is 0. Sorry, tan 0 is 0. 0. And this is tan infinity is for tan 90 degree. Pi by nothing but pi by 6 answer. Pi by 6 answer. Okay, 1.3 into pi by 2 is pi by 6. This is the answer here. Final answer pi by 6. Question number 12. This is proper substitution method which we are doing here. In case of indefinite integrals, we do as an indefinite integral and the limits are applied finally. That is the extra task here. Okay, so 12th question is done. Let's talk about 13th question. Sine of integration, sorry, this is 0 to pi by 2. And here it is sine square x dx. Now we know that sine square x equal to what in terms of cos 2x. Now since, sorry, cos 2x, what? Let that is sine square x equal to 1 minus cos 2, okay, or cos 2 theta. In this case, let me take here theta, this is also theta. Since cos 2 theta, this we have discussed a lot. 2 cos square theta minus 1 or 1 minus 2 sine square theta. From this formula, this one, we have taken this 2 sine square theta taken this side, or this cos 2 theta that side, it will be 1 minus cos 2 theta equal to cos 2, 1 minus, sorry, 2 sine square theta. In place of this sine square theta, we have to divide by 1. Therefore, sine square theta equal to 1 minus cos 2 theta upon. This is the value here. Let me first substitute it as 0 to pi by 2. It is 1 minus cos 2 theta, cos 2x, sorry, cos 2x upon dx. Now here, no need of substituting the value. We can just integrate this. Okay, this is 1.2 that we take common. First is sine of integration. This is dx only 0 to pi by 2 minus cos 2x on integration 0 to pi by 2. Now let me integrate this. Now cos 2x we do directly. Okay, even we can substitute 2x also, no problem. But let me do it directly. This is dx means x limits are for this 0 to pi by 2 minus sine cos 2x is sine 2x upon 2 0 to pi by 2 limits 0 to pi by 2. Okay, this is 1.2. Upper limit is pi by 2, that is pi by 2 minus 0. This is this minus sine, let me substitute here. This is sine 2 into pi by 2, that means pi only, pi 0. This 1.2 are taken common. So this 1.2 here, this is 1.2 here. Okay, minus minus plus in between. Then sine 0 0. This is also 0. Both are 0. Sine pi is 0. You know this. That means 1.2 into only pi by 2. The first question. That means pi by 4 answer. The answer is pi upon 4. This is the only answer here. The question is, this question 13th is solved. Then this way we can solve it without substitution. Or if